Many times I have talked about doing work in the background. Now we will look at one approach that Android supports called as the async task, which makes it easy to do work in the background. Now, you have heard me many times mention about the main UI thread and background thread and so on. This diagram is to clear up in your mind what exactly is it that I am talking about. Now, when you write an Android application, all the code that you write for your Android application is running on a single thread. In Android, this is referred to as the main UI thread. And this is responsible for updating the user interface and keeping the rest of your application running well. Now, if you are familiar with threads, you realize that typically a process or an application has a single thread of operation, but if your platform supports multi-threading, then you can easily spawn threads in the background to do work for you, and then when that work is completed, the background thread then can come back and then give you the information after the end of its processing. Now, how exactly is this done in practice? When we saw the surface view, we saw how we could create a background thread and then offload the update of the canvas to the background thread. Now, threads are a wonderful way of achieving this in practice, but threads are sometimes difficult to deal with, especially for people who are not familiar with multi-threading. And you can easily tie yourself up into knots trying to make your code work. Now, this is where the async task comes to your rescue. The async task makes it very, very straightforward for you to dispatch work into the background. And also, whenever you need to do some updates to the user interface, it allows you to execute some of the code in the foreground in order to do the user interface. In Android, it is a must that any updates to the user interface has to be done on the UI thread or the main UI thread. No other background threads can update the user interface. So, which means that even if your background thread has done some work and wants to inform the user, it needs to depend upon the UI thread to do that work on its behalf. So, the use of threads involves, as your program is executing at some point in time, your main UI thread may decide that it needs to do some work in the background, and that's the point where it'll spawn a background thread, or it'll start an async task and then offload the work for the async task. The async task does its work in the background, and then when it is completed, it'll come back and return the result to the main UI thread and ask the main UI thread to update the user interface based upon the result. Now, threads, as I said, are a very powerful method of doing background work, but the code gets very complicated when you're using threads. Especially for novice programmers, it is incredibly difficult unless you understand multi-threading in a lot of detail. Async tasks simplify this by allowing you to define certain pre-specified methods that are supported in the async task, and it clearly tells you which parts are going to be executed in the background and which parts are going to be executed on the main UI thread. So it takes care of the thread management on your behalf, so you don't need to worry about all that. So how does async task work? Now, async task provides you with several features. It allows you to return values of specific type to the UI thread when the task is finished. It has the ability to execute code on the UI thread even before the background task is finished. So for example, if you want to periodically update the UI, having completed part of the background work, that is also feasible with the async task by enabling you to push updates to the UI thread while it is doing the background processing. And async task completely manages the threads underneath in an automatic way on your behalf. Let's look at a quick example of the async task. Indeed, you have seen the async task being used in the exercise in the previous exercise that you have just completed. So we saw that we had three methods there that we used: on pre-execute, on progress, on post-execute, and the do in background. We didn't use the on progress update method there because we didn't have much to update the UI at that point. The on pre-execute, on post-execute methods of the async task will be executed on the main UI thread. So in these methods, you can update the user interface if needed. The single method that is done in the background is named do in background. What an obvious name for a method. So this method, whatever code you include in this method, is going to be executed in the background thread, and when it completes, it'll come back and return the result. Periodically, inside the do in background thread, you can call an Android frameworks method called as publish progress. When you call this method called publish progress, what the Android framework will do is it'll come back and call your on progress update method. So in the on progress update method, you can include code that might update the user interface. So that is one way of periodically updating the user interface, even while you are continuing to do the background task. Okay, so again, summarizing, there are several methods that are part of the async task. So the async task is a class, as you might expect. The do in background method executes whatever is included in that method in the background. The on pre-execute, on progress update, and on post-execute methods are all executed on the main UI thread. And you can call publish progress from the do in background method at any point in order to update the user interface. When you call the publish progress, Android framework will come back and call the on progress update method, and that code will be executed on the main UI thread. You can also cancel the async task at any given point of time. So for example, if the user suddenly exits the activity which spawned the async task, you can easily exit the async task at that point. Now let's move on to the next exercise, where we are going to learn about how you connect to a server using the HTTP URL connection object, and also how you get a JSON string from a server.